Detection of enzymes. Determination of enzymatic activity require a retraction. Many analytes of interest are themselves enzymes. To measure the amount of enzyme present, a substrate that is recognized only by that enzyme is used. For example, the enzyme lipase releases fatty acids from triglycerides and diglycerides. Lipase activity is measured by using product from lipase action on diglycerides to generate glycerol molecule. These glycerol molecules produce a color product that absorbs light at 548 nanometer. The rate of increase in the absorbance of 548 nanometer is a function of lipase activity. Enzymatic reaction can be coupled and occur in multiple steps within a chemistry test. And here some examples of enzymatic activity. Antibodies. Antibodies immunoglobulin are formed by the immune system in direct response to foreign substance called antigen. Deliberate exposure of an animal to an antigen immunization generate antibodies that are specific for the antigen. The antigen may be analytes like proteins, transferrin, or drug amikacin. The antibodies produced by such immunization are termed anti-analyte antibodies. For example, antibodies produced by a goat against a human transferrin protein are called goat anti-human transferrin antibodies. Antibodies produced in a rabbit against the drug amikacin are called rabbit anti-amikacin antibodies. These antibodies can be used to selectively measure transferrin or amikacin in human serum sample. Example of format for assay using antibodies immunoassay include immunoprecipitation, immunocomplex. Antibodies to protein antigen can be bound to multiple sites or epitopes on the protein molecule and can cross-link many different molecules of same protein to form an insoluble precipitate composed slowly of antibody and antigen molecules. This immunoprecipitate can be detected using turbidimetric methods. For example, the protein transferrin can be mixed with anti-transferrin antibodies and the resultant immunoprecipitate can be quantified in turbidimetric rate endpoint reaction. Here the transferrin, the antibodies to transferrin, insoluble complex, particle enhanced turbidimetric inhibition immunoassay, Bithynia, and particle enhanced turbidimetric immunoassay, BTI. When analytes is small molecules that can't be cross-linked to produce an immunoprecipitate, it is still possible to use turbidimetric method. A microparticle is coated with the analyte. When suspended in solution, the microparticle is too small to affect light passing through the solution, but when antibodies to the antigen are added, the particle aggregate into large complex that prevent passage of light and can be measured by turbidimetry. When antigen is present in the patient sample, it competes for antibodies and prevent aggregation. For example, if the drug amikacin is coated on the microparticle and these amikacin particles are mixed with a serum sample containing amikacin, the turbidimetric signals upon addition of anti-amikacin antibodies will be much smaller than when no drug is competing for the antibodies. The decrease in rate of formation of light-blocking particles can be correlated with the amount of amikacin in the serum sample. Here, microparticle coated with analyte. This is antibodies. In absence of the drug in sample solution, particles are extensively cross-linked by antibodies. The presence of the drug in a sample solution can be detected by the decrease in turbidimetry due to few cross-linkage. enzyme multiplied immunoassay technique. In this format, an analyte of interest in serum compete with modified version of the same compound for antibodies to the analyte. The modified version is linked to an enzyme. The enzyme is active unless the attached analyte is bound to the antibodies. For example, theophylline linked to the enzyme glucose 6-phosphate dehydrogenase generate a product called nicotine diamine adenine dinucleotide phosphate NADPH that can be measured spectrophotometrically. When the theophylline enzyme complex is bound to anti-theophylline antibodies, no enzymatic reaction occurs and no NADPH is produced. If the drug theophylline is present in serum, can bind to the anti-theophylline antibodies and replace the enzyme theophylline complex, allowing the enzyme whose active site is no longer blocked by the antibodies to produce NADPH, which measure optically in the UV region at 340 nanometers. The more theophylline in the serum sample, the greater the amount of free enzyme theophylline complex and the more NADPH produced. Addition of anti-drug antibody inactivate drug-linked enzyme resulting in no enzymatic activity. Drug and the enzyme, antibody to the drug and the enzyme become inactive. When a sample containing a drug included, the drug compete with the drug enzyme complex for antibodies, and not all drug-linked enzymes are inactivated. The more drug in the sample, the greater the enzymatic activity. Drug enzyme plus drug, antibody to drug. Free drug compete for antibody, allows some enzyme to remain active. Ion selective electrodes, specially designed ion selective electrodes, allow potentiometric measurement of the single type of ion without interfering from other ions. Ions that can be measured in this way include sodium, natrium, Na, potassium, kalium, K, chloride, lithium, calcium, magnesium. ISE use membrane with very selective permeability or sensitivity to an analyte, ion size, and charge. The membrane may be have pores that limit the size of ions that may enter the membrane. They may be impregnated with chemical called ionophores, which allows only selected ion to be sensed by the electrode. For example, a polymer membrane that incorporates an ionophore called varenomycin is highly selective for potassium with little to no response to physiological concentration of other ions like sodium, calcium, magnesium. An ion selective electrode of this design is ideal for measurement of potassium ion in the presence of physiological concentration of sodium ions with no bias caused by the larger number of sodium ions. Potentiometer, the reference electrode, ISE, select potassium, ionophore varenomycin,